Hello, you absolute legends. We have up here a balanced chemical reaction between a base and an acid, and the two products would be an ionic compound and some water molecules. I want to first kind of talk about the story behind this problem before we talk about, we're eventually going to, before talking about the calculation at the end right there. Spoiler alert, we're going to be calculating how many grams of this will be produced. So we have buckets for each of these compounds right here. I shouldn't say buckets. Let's say right here inside this is the calcium hydroxide. And I have stars just representing the calcium hydroxide. And let's just say that this is full of an infinite amount of calcium hydroxide. Like we just have more to spare. Okay? And the nitric acid, by comparison, we do not have an infinite amount. We have a relatively tiny amount. Okay? Now, the story goes, this tiny bit of nitric acid is going to get poured into here. These molecules will collide with each other and reactions will happen as a result of those collisions. That's chemistry. How many grams of this stuff will be produced calcium nitrate? It's said that, we have a lot of this stuff here and we only have a little bit of the nitric acid. So we only need to know about the nitric acid, knowing that that's our limiting reactant. And in this case, we have 150 milliliters. This little container is 150 milliliters, and we know it is 1.5 molarity or moles per liter. And again, that's of the nitric acid HNO3. This problem is going to be performed in two scaffolds, in two steps. And let me write out that plan right here. We're going to do some solutions with nitric acid. And that'll be our first scaffold. And that is just to get the grams of HNO3 that are present in this tiny little jar. And then our second scaffold will be a grams of reactant, HNO3, and grams of product, CaNO3 dose. So this is solved in two scaffolds. Let's get started. Our solution right here, we're eventually trying to solve for grams of HNO3. This is all I know about the solution. It's 150 milliliters in its concentration. None of this stuff contains grams. Ugh, I'm just going to throw something down. Like, just going to put down something that I know is true, 150 milliliters. All right, that is a true statement. Awesome. Can I cancel out a unit? Almost. Milliliters and liters are cousins of each other. Let me convert this real quick. So I'm not going to do the little conversion. I'll do it in my head. 0.15 milliliters is the same thing as 150 milliliters. Now I can cancel out liters. Awesome. Okay. Now, like I said at the beginning, I don't see grams show up here yet, but I'm hoping that this jogs your memory to think about moles. I'm trying to solve for grams. Ding, 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 ding. The molecular weight contains both those units, grams and moles. In fact, it's grams per mole. Let's calculate the molecular weight of HNO3 to plug into our scaffold. $63 grams per mole. Now I got to make those unit. I got to make that unit mole cancel. Whoa! Look at this. At the same time, by making the mole unit cancel, I solve for what I'm looking for. It's not a coincidence, but you should always persist to cancel a unit when stuck. I could punch this out right now and solve for the grams of HNO3, like just what that grams is right there, but it's not my final answer. I could calculate this, pick up my calculator and get the number, but I don't. It's not my final answer. I can continue to build this scaffold based off of this one right here. But right now, for simplicity, I'm just going to calculate this. But I challenge you in harder problems to continue to build the scaffold. This is 14.175 grams of HNO3. So that's how many grams are inside that tiny beaker that got poured into the big one. I'm going to erase the scaffold here. I need the room. For my second scaffold is a grams to grams type problem, solving for grams of reactant to grams of product. 14.175 grams, I'm just going to say 18 grams of HNO3, 63 grams per mole, the molecular weight of HNO3. So with the number of moles of HNO3, I can use those molar ratios from the balanced chemical reaction to get out how many moles of this stuff would be made, or how many of this stuff would be produced in this reaction vessel. 2, I got to remember to carry the big numbers and all the baby numbers from the balanced chemical reaction. Finally, my last step in a grams to grams type problem is calculating the last step in a grams to grams type problem is looking up the molecular weight of the formula that's not crossed out. (164 grams per mole). I'm just going to make sure that moles cancel when I lay that down. And it does from the 3-point line. So now I can pick up my calculator and I'd solve for this second step of the second scaffold. Excuse me. Recommend you multiply everything across and then just hit the division button. Don't try to use parentheses. 18.45 grams of calcium nitrate could be produced if this tiny little thimble was poured into this 5-gallon bucket. I hope this helps. Thank you.